let's discuss the placement part now, right? So we discussed floor plan exit and floor plan aspect. So, so before you do placement, what are the things that we need to check?
Is there any power floating bits are there? All the macros placed perfectly on the- After that, is there any, if you are using multi-voltage design, we need to check the all the cells will be uh, cells were placed or not. And whether the data flow diagram it matched or not.
Anything more?
Not just. Not just on.
I have one doubt,
What to
sir.
do? What are the typical questions in placement you get in the interviews?
Last type of question, condition.
Sir, I have one doubt, sir.
Yes, go ahead, ask.
Sir, data flow, where we'll get a data flow chart?
The customer will provide you. Ask for a data flow, ask for the explanation of the design of your block. He will provide you that. Okay, so you need to ask for 2-3 things from the RTL design. So one is basically a data flow diagram, right? You can ask for the clock diagram, right? To understand, how your clock structures are there, what is, what is to be specified, etc. And then we need to ask for I've already told, right? Interface details, budget, etc. We have already discussed what we have to talk to RTL designer, right? What you have to talk to the synthesis guy, what you have to talk to the DMP engineer, what you have to talk to your library team, right? We have discussed all that. So before you do placement, there are few things which are very important. First, do you all understand what is a temperature inversion? What is it?
Yes. Sir, it is actually coming to lower technology. As the temperature increases, the cell delay will be decreases because of it is mainly depending on the threshold voltage.
Huh. What is threshold voltage?
Uh, as a drain current increases, the mobility of the cell will be uh, decreases. So the threshold voltage will be decreased, and cell delay will be decreased.
Up to 300 kelvins, mobility of electrons is directly proportional to temperature.
Ah.
So as mobility increases, the drain current will be decreased. The recombination of electrons will decrease, so drain current will decrease. After beyond 300 Kelvin, mobility is inversely proportional to temperature. As temperature is increasing, mobility starts decreases. So drain current in the semiconductor will increase. This affects the flow of current inside the semiconductor.
Yeah, because the higher technology it is
Temperature is
depends
not
on the
increasing.
mobility, whereas in lower technology it is depends on the threshold voltage.
Actually, you see there are two aspects to the delay of a cell in the CMOS step. One is called the diffusion impact. The second one is basically the mobility, current flow mobility of electrons. The mobility of electrons as the temperature increases due to hot electron effect, what will happen is it's a resistance, right? The path from source to drain will be a resistor path. Okay, that will always be, as temperature increases, that will increase the resistance increases, there will be delay. But diffusion is about recombination, right? You know, what happens is there when you're looking at the transit time, right? So that one, the channel thickness reduces at, lower technology so that the faster as the temperature reduces, what would happen is there is a diffusion problem. And then, your delay is also increasing even at the lower temperature because the diffusion gets dominated. So you need to understand that there's a resistor effect and there's a PN junction recombination there. Okay. These two are converged. This is true in higher technology or lower technology, both the cases. But it became more obvious in 90 nanometer and below. Even the lower temperature corner also became a critical path. Higher technology, higher temperature will, the cell delay will be more on. But even in the lower temperature, because of the diffusion problem, it started to actually increase the delay of the cell. So we cannot clearly say that, lower temperature corner will be critical or higher temperature corner will be critical. It depends on what the library and how it is being positioned, what's your net length, everything. But both the corners became critical for 90 nanometer and below. You understand? There is a mobility and there is a diffusion. Two effects are there. So you can look at what is actually the temperature immersion effect in this case. Okay, and you'll get more clarity about it. I don't want to detail the physics side, but the reason why I asked this question is typically in an interview, they'll ask, okay, which all corners you are actually closing your timing. What are the things, what are the inputs that's needed? Somebody has to provide you a scenario file. Right? What is the scenario file? In the scenario file, you will have all the different libraries, corners, voltages, if you have multi-voltage, etc., everything defined in your for your mission critical corners. Because when you're doing placement, your focus is on setup time. But your hold should not be violating. I mean, in the sense that the skew effect, you don't worry, but it should not be violating more than like 30 because if it's like nanosecond, that means there's a constraint problem. First thing before you are doing is make sure the constraints are relatively clean. Formal verification, that's what check design, check timing, right? There should not be any DRCs, floor plan DRCs. If these are all there, then legalization problem will be there. Your run times will get increased. Your utilization should be reasonable. If you have created region, make sure the regions are not more than 70%. Okay. So things like that, you have to make a basic set of checks. And you have to run both your worst corner and your best corner at the placement should be set to your worst corner.
Yeah, always should do.
Okay, so that there's no confusion. It doesn't have to do hold check or something. Its focus should be on setup time. Okay, there should be timing constraint. There should also be physical constraint. You should keep, yeah, PD level, whatever your DRV, etc., you have to keep. Scan-def file is required, right? You have to make sure that the scan-def and this one are matching. Whatever is actually happening, if there are differences, again, you will have a problem. Right? Run one, go through, make sure that the cells present in the scan-def is also present in your netlist. Right? Because some deletion would have happened or certain things would have happened. So all these make sure from a library point of view, you have all the frame views or you have all the lefts which are required for you to do your placement. Okay. Placement, again, you have to segregate into three parts. One is your initial placement. So when you are doing your first set of trials, try to save a database, okay, intermediate term after global placement, after course placement, let it do a term. So that you can read that data and figure out your global your initial placement is good or not, by which you don't have to wait for the full, because sometimes if your floor plan is bad, your runtime may take 4 days, 5 days, and it will crash. You want to be able to, sir, it crashed. I don't have any data. Problem is with you. Right? You have to share something because the optimization and so on and so forth, you have to monitor it properly. Okay, so ensure that the characterization, everything that is set and whatever you have set for, in your scenario files, like your don't touch cells, you have to enable only SVT, LVT, all these checks should be done thoroughly. Don't touch, what's the type of cells I'm supposed to use? Zero drive cells may be there, okay, which will show good timing over here. But afterwards, what will happen is if you start failing, you won't be able to get anything. So you have to hide. You have to make sure the quality of the library you are feeding to the placement is pakka. It's of good quality. If you are giving zero drive, which is of no use, but just trying to do, that means
You have to make scenarios also, right?
Yeah.
Yeah.
Yes, you have to do scenarios. Okay, you have to keep at least, if you are having multi-mode, multi-corner, right? Like don't run placement in 20 corners. No. As I said, mission critical. 2, 3 corners. That's what you should keep simple.
Sure.
Especially initial trials, you have to keep it very, very simple. Maybe just focus on PVT for that. Don't worry about DFT. Okay, keep that all critical and make sure that you are feeding the right kind of margin. Even when you are looking at your clock uncertainty, etc., give a reasonable value. Okay, maybe 5% of your frequency, something like that. If you are looking at transition time, look at it at about 25% for the data and this one. And also ensure the clock NDRs are also defined before you run placement. Because what happens when the global route is being generated, if your clock NDRs are properly defined, right? You need a double width, double spacing for your clock. You have not defined NDR at placement. It will do a single width. You will see condition is good, but post CTS, your condition gets screwed up. So defining your clock NDRs and metal layers before placement is also equally important. Clock cell should be of clock type. Retain that. Clean up your database before you are entering so that you are trying to mimic the real scenario, because you want to actually estimate the issues upfront rather than struggling later. If you don't fix it right here, after CTS again you will have a problem. Again you have to come back. It's a costly, expensive process for you. If you have to change because then whether you have to change the size or metal layers, you can do at the placement.
Placement.
Yes, so define as many things, but simplify. Keep it mission critical. You understand? Okay, if you are seeing, and whenever you are running placement for the initial trials, don't try to focus on your IO type name. Okay, keep IO's rule. First, allow your internal timing, whether they are meeting or not. You have to understand whether the register timing, whether these things are actually causing you. Because if you are keeping everything open, you won't be able to debug where the problem is coming. If this timing is closing, then you are tightening the IO timing in your second iteration or third iteration, because of which your database is getting screwed up. You have a feedback to give to them. If they are given, because they will give some estimation. How do you know that is true or wrong, right? You have to actually control your database really well. A lot of people don't know because you don't know, right? Somebody is giving, you think that is golden data, you are running like a machine. It is not working, it is not working. So first, don't focus, keep the IOs loose. It's okay. You make sure at least they are constant. all the IO should be constrained. That means by default, you just run 70% or 60%, 60-40 budget. 60% for the top level, 30%, 40% for you. Or 50-50, initially loose. You can keep it loose. Okay, then you go and tighten. Second iteration, because you want to identify. Yes, because you are working on floor plan. These are all, see, placement is not, you should not run placement like you are running in the final iteration. You are doing your initial trials. For the initial trials, your idea should be, when I'm doing my placement for my initial trials, it should run fast, quickly. It should tell you where the congestion is. It will give you the quality of timing. I should be able to get as much information for my floor plan as possible. That should be your goal. Okay, as much as possible to the quality of the. Put all the blockages necessary. Macros, everything. Let the cells not go and sit in the corners. Don't think there are DRCs here. I'll fix it later. Then you start removing it, will create money. So create as many constraints, but simplify the design and run it at a quick shot. Initially, you can run whenever you are running placement initially, run everything on a medium scale. Meaning, whenever you are giving place off, for example, you don't give high effort congestion, don't give high effort timing, because you don't know what the tool is going to do. First, you have to understand where the problem is. If the problem is really congestion, then you put that knob. Don't try the knob from initial itself. Use a default certain things. Enable can chain reordering. Make a check. Okay, so that what happens is when it's trying to connect the scan chain, that should not become a constraint for the tool to not place them far away. If you are not allowing that, it will try to place that close, then it will screw up congestion somewhere, it will screw up. So you should always enable scan chain reordering. Is it all clear? So when the questions could be how we are going to resolve congestion, or where first thing I am going to do like this. Okay, identify. Then what I'm going to do. You understood, right? The process is run that, identify, check the course placement, global placement, and see what's your net length. You have to, this you will not at all look at when you are doing in your PNO. Because that data, nobody is asking for net length, everybody is asking for congestion, everybody is asking for timing. Okay, timing met, okay, congestion met. No, you have to understand how your net length growth is. After every iteration, you have to make a note. If your net length is becoming more than 5 kilometers, so after the next iteration is becoming 6 kilometers, means 1 kilometer of additional net you are adding. No problem. It will eventually impact your congestion and timing. Hi, Deepa. How ನಾನು ಮೀಟಿಂಗ್ ಅಲ್ಲಿ ಇದ್ದೀನಮ್ಮ, ಕ್ವಿಕ್ ಆಗಿ ಏನಾದ್ರು ಫೋನ್ ಮಾಡ್ತೀನಿ. Okay, run it loose, keep the IOs loose, then you tighten it. You have to run parallel experiments. One, your goal should be congestion should be 0. That's your first target whenever you are running. Run global placement, analyze if it taken 2 days. So while it keeps running, I'm going to look at this. I'm going to look at the log file. Once the data comes, I'm going to start analyzing the global placement, what you are going to analyze, course placement, whether my modules are getting placed properly. If your modules are getting distributed, then there's a problem with your macro placement. You can stop, go back to macro placement, create that second iteration quickly. You don't have to wait for 4 days. Second day, you will have another floor plan. Every day. Yes, keep running. So get that global placement, get that module placement reasonably good. That's the goal of initial course placement. net length, course placement, net length, congestion, enable, route. Okay, you will get a course placement, run one stuff and then check how the things are. பிரதீப் கிடைக்கும், நான் உங்களுக்கு அனுப்புறேன். அது வேற அட்ரஸ்ல இருக்குது, தரேன் நான் உங்களுக்கு. ஓகே, என்ன இருக்கு? இல்ல, நீங்க புஷ்பா கிட்ட பேசுங்க, நான் உங்களுக்கு நம்பர் கொடுத்துருக்கேன், அவங்ககிட்ட பேசுங்க. நான் சொல்றேன். ஓகே, okay.
Sir, how we will know that modular is spreading?
How module is splitting?
Yeah.
For each module, you have to give a color code. This is
Color
what you have to
hierarchy.
do, right? Hierarchical viewer, when you are looking. So hierarchical viewer, how do you actually look at that? There's a big top level name for you. Then you can actually, when you are clicking on that plus sign, it will break. It may break into one very tiny module. Let's say you have 1 million instances. Okay. And there is one module which has only 100 instances. One module which has 99.99K instances. Then there's no point in looking at this very tiny space. Again, click on that 99.99. It should be something like you are looking at 10 module pictures. Some 100K, 200K like that. Because that is what is very critical for you to actually analyze. Okay.
Yeah, actually, sir, at floor plan, we are like creating according to that color hierarchy, no? Then how it is split on placement? That I didn't understand.
In placement also,
Uh,
there is a color hierarchy. We can make a map of color hierarchy for standard cells.
you can create a tickle file which says get change selection, get cells of that pattern, whatever that module internally, and you can put that, once you are selected, you can put that as set object, some set color pattern, etc. There will be some. You can put attribute or you can use the GUI to set the color pattern.
Okay.
Okay. Set attribute, you can put color code for that. Okay, use the attribute forums for doing all this. You can do, you do any get attribute minus application minus class cells. It will tell you whatever is the color object, etc. You can put that attribute. You have to set different color and you source that file. After you have done your placement, it will tell you how the color map is. Then you can look at this guy's color is like split, then you will be able to identify whether it is split or not.
Okay.
Simple. Or in the GUI, you have to select and right click, there will be a color. You set that color. You understood?
Yeah, yes, sir.
Okay. So look at this color module, color mapping, and then make sure that this particular iteration is going on and keep a track of your net length. Look at how the things are progressing in your log file. In your log file, if you are seeing that in between suddenly there is a utilization jump, where is it happening? You have to identify that step where it is happening. It will say buffering, okay, fixing DRVs. At DRV fixing, suddenly your utilization is jumping from 60% to 74%. That means, what is the thing that it is saying?
Unnecessary things extra buffering happen.
Extra buffering happened. So how are you going to fix this problem?
Need to check where it is happened, means necessarily where it was placed. Instead of buffering,
No.
we can.
There are two possibilities. Module splitting, because of which, something you are actually thinking, basically there are net products. Then you take three possibilities. The other thing is basically some high fan out nets are not being set as high fan out nets. Because of which for one net, it may be adding hundreds of buffers. So you have to actually set high fan out net synthesis limit of 100. Anything more than 100 should be treated like a high fan out net synthesis. Then automatically the idea of normal buffering to high fan out net synthesis, you understand, right? High fan out net synthesis will create like a clock tree. Okay, in parallel, like logarithmic scale, right? One buffer driving 16 or something like that. You have to set a for your default. Okay, for your PNR, you set maximum fan out 32. Maximum cap. Okay, some 50 femtofarad. 100. Okay, like that. Max transition. For data, set it like 40% initially, 40% of your frequency. For clock, you can set it like 20% of your frequency. Something like that. This should be your sort of default approach.
Sir, how to decide that max tran and max cap, that value?
That is another class I will have to take. I'll explain, but use this default because this focus, I'm focusing on interview and I have to finish placement and CTS,
Okay.
etc. So think about it. How do you decide is there are two factors. One is your library characterization, whether it is 30, 40. If it is 30, 70 means the 30% of your voltage to 70% is what is taking your transition value. That means from 0 to 100, it is like 60% is not measured. If it says 30 to 70 is taking 1 nanosecond, extrapolate it, another 60% will take 1 divided by 0.4 will be 2.5 nanosecond will be its actual transition. That's the problem. So whether it is 2080, 1090, by default, many libraries come with 1090. So rise time is between 10% of your thing to 90%. This is what your textbook will tell.
Yes.
But that depends on the characterization. If the characterization is 30, 40, that's what you have to take. Okay, so I will explain all this. By default, library transition time will be taken, but you should also in addition add your frequency related stuff. Okay.
Okay.
So add this and run your placement. Then you tune your knobs. Now, if you have, what are the typical questions in an interview? Okay, how are you going to analyze condition? What is your answer?
Check the condition report, you can see where is the hotspots.
What is the condition report?
The condition report where is the routing resources not available, means is not available for the requirement. Can check 3 times. In congestion, self congestion, global congestion.
So congestion has visual checks and report checks. Okay, and also there's something called scenic routes. Scenic routes. Scenic routes means you are expecting the net route to happen in a Manhattan way, shortest path, right? Scenic routes mean detour paths. So if any route is taking more than 15%, in addition, that means more than 1.15x, you can set that scenic route scenario. More than 15% of your default route length. That means there is a lot of detour happening. They are all called scenic routes. You have to analyze them also. Why detour is happening? That means there is congestion in the point. There should be something. All this would add further congestion to you. You understand? So scenic routes can be a floor plan problem. Because you have not left a notch, let's say for memory to connect, you have not left a spacing. So what it will do, it will try and do somewhere snakes will start appearing. All these are problems. It will tell you.
In that, so too many cells will be there. How will you decide? How will you find that detour?
You can report, you can set a variable, scenic route 15%, it will tell you that more than so many nets, 1000 nets are scenic routes. You can list out, give me the net names, it will give you. You can do all that magic. Okay, so you have to analyze congestion. Visual congestion, how will you analyze? First thing you have to look at is cell density. Before you look at anything else, look at your cell density once the placement has happened. Okay, first, anyway, you will have to look at the log files where the growth is. Before you do anything, your utilization between pre-placement, that is floor plan, to your placement. You should not see, um, one of the things that you have to be very clear, right? Whether if you are seeing more than 4%, 5% growth, the one obvious question, let's say there is a 10% growth. One question you should ask is whether synthesis was done using SPG or was it like a DC synthesis? SPG means they may not have used your floor plan. You can give the feedback, and if you are seeing your timing is not converging, that means it could have used, they may not have, you are the one doing floor plan. No, you have to before. So this is a very important loop. Don't assume synthesis is done. After you do a reasonable floor plan, one couple of iteration, you have to give that floor plan data back to your synthesis, dump out a def file, ask your synthesis guy to run using this floor plan, enable SPG, so that what will happen, the DC has more option to break this out architecturally. It will optimize.
DC means design compiler.
Design compiler.
SPG means
Design compiler topographical. Yes, DCT, I'll tell you, DCT has two options. SPG means it will use your floor plan bus. Design compiler topographical without floor plan also it will do. Okay? The difference between DC and DCT is DC will do just logic synthesis. DCT can do placement. So if you don't give floor plan, it will do DCT placement, it will do by default, like automated floor, automated macro placement, automated, but it will do placement, it will do legalization, then it will do. Okay, so these are things that you could have done. So in a DCT scenario, you should not expect like more than 3% growth between your floor plan to placement.
3%.
Roughly, definitely should not increase 5%. But 3% is a reasonable guess within 3% limit. If you are seeing 10% increase, etc., that means there's a problem. Since that means you have to increase. Okay, 70% when it closes. So keep giving this feedback. Don't assume what you have got is a golden necklace. You have to give.
The floor plan, we need to put the system.
Do if for example at the floor plan stage, after that your timing is meeting, your utilization is good shape, you don't have to worry about synthesis. Your tool is doing good enough job for you. You don't need. If there are problems, if you are seeing growth, then you go back to the feedback. In a floor plan, as I said, right, when you are doing placement, you have to ensure that if you have to do spatial insertion, etc., you have created the necessary stuff and they get priority. In a flow, before doing placement, you have to make sure all the specific constraints, that is path grouping, etc., whatever is there, critical paths, you have set actually, critical range, you have set everything, net, everything, one after the other, you will start building. Your placement is never one iteration, right? It's a process. So you will learn, you will feel, you will ask the tool to improve where the things happen. So you have to work it out structurally like this. And then work on what you have to do for post placement, whether you need timing optimization or you can do it at only the piecing up stage for you to converge. These are important things where you have to do. Okay, you can break it down into different pieces or you can run it at a single place opt minus buffer only option minus this option, blah, blah, blah. So place opt also you can run 3-4 times. Place opt initially you may get something, it's not meeting. So then you enable PC opt minus timing driven. So then again it will run another iteration. Okay, IFR. So this is also script that you will have to create for your own stuff. Don't assume what tool has given. You will have to create your convergence flow. That is what is placement. You have to create a convergence flow. What will enable you to converge your timing and this one? They will give you a set of commands. They will give you a base flow. But if you have to do some things, you have to converge. Hey, I'm getting this. Can I do one more piece in up? Then one more iteration. Then you'll have to experiment with options, with additional runs, etc. Whatever is required. You understood? So congestion, when you are analyzing, first thing you will look at is placement density, cell density. And if you are seeing cell density, okay, and cell density is high somewhere. That means what are the options you will look at? Why is it high? Okay, cell density can be high basically there because the timing is very tight in that area. Okay, timing may be tight because you have given very tight IOs, for example, IO timing constraint. Loosen it. Check whatever is the problem. Or IO uh, placement utilization is high. Basically the tool has done something. You try with some density screens. That's another option that you can actually try. Okay, or try to change the floor plan. Okay, because you may have packed too many macros, you just spread, allow the tool to have. So anything more than 90%, density is a problem for you. You should get mostly at placement stage, you try even yellow spots are dangerous. Yellow is red for you in placement density. You should get as much as blue. Okay, and some spots of green. Blue means everything is like within 70%, 60% or something like blue. Green is between 70 to 80 like that. Yellow means it's almost 100%. 100%. Red means it is, of course, there are actually overlaps. Right? You understood? You have to look at placement density. Next, you enable pin density. Your placement density is, let's say, very low. Okay. Your pin density is actually got a problem. So then what you do is look at, analyze that and see why the pin density is high. If you're seeing that in that area, there is a high concentration of complex cells. Okay. Then one of the things you can look at is break them down, or you say you can use cell padding is a later stage. Okay, if you are seeing, look at one report area. Area report will report all the cells and percentage of use. So if it is using too many complex cells and percentage is like more than 10%, 15% complex cells. Okay, and this is of AOI cell, but it's using AOI cell also has many variations. AOI 3 may have 8 pins. AOI 2 may have 6 pins. I'll avoid 3 pins. So I'll put don't touch on that cell. Don't use this particular cell. So go back to your placement. Just don't think it's using complex cell. I'll put a density screen. I'll put a cell padding means it's not the right solution because you will impact the timing. So one of the things you should look at is, can I knock those cells off from my optimization? Can I give it a different flavor so that the tool can try out something else? You understand? Look out what you can mask so that the tool does a better job. And it may converge, it will do. These are all techniques that you have to play. So here's the 8 pin, here's the 10 pin. So all these are data. You would have never even looked at it. You're assuming what is coming is like some golden card given stuff. Bagav. Huh? So don't do like that. Look at what is being used. That's what is the designer. That's a good job. To look at that in detail and then start to look, okay, these cells are good, these cells are causing a problem, or there's a problem why this guy is happening because I'm seeing some other problem I would see. For example, this memory, I'm seeing a lot of congestion, or there's a problem, my congestion map is coming at the feed through level. Okay, feed through levels, it is happening. Then there's again a problem. Okay, we'll talk. Feed through is one problem. Near the memory, you are seeing congestion. How will you address that? Memory pins, there is a congestion mean. Why should the cells sit closer? The cells are sitting closer because there's a tight timing to it. One of the things that you can do is you will have to add series of not just one density screen, but maybe 2-3 density screen. Near the closer to the memory, you add like, I don't want actually partial blockage is 80% blocked. I'll use another screen after that for up to 20 micron thickness. Sorry, for 10 micron thickness. After that, for 20 micron thickness, I'll allow 50% of the cells. After another 20 micron thickness, another partial 80% of this 60% can sit. That way, you are allowing the tool certain guidance so that it doesn't cluster near to memory. Similarly, when you are looking at the pins, etc., near the pin, okay, you avoid, too many pins means you can avoid near the feed throughs, some blockage. Similarly, blockage, you'll have to add some series of blockages. Okay, it's not like one tip I have given and it's over, not like that, or just change. You may have to look at how you add blockage also in a fashion properly. You understood? So you have to analyze the data and then look at how to actually take that density of this. Okay, why this is actually happening and make a proper distribution. So pin density, of course, you can give the feedback, you can remove those particular complex cells. Second approach is obviously you can enable cell padding, to allow that, into that, or you can even do module padding so that that module gets reasonably placed. If you're seeing that module is tightly packed, this module is very routing intensive. So I want to make sure that it is broken down properly. You can look at module padding also. You understood? Select this entire module and put some padding. Okay. Try to address as much as possible from a floor plan perspective. Okay. Don't try to add tiny blockages, too many things. It will be very difficult to control. But if wherever required, and if you have notches, okay, around the notches, it could happen that cells are trying to sit on either side. So you create a blockage such that the cells can smoothly cross, not like sharp turn. Okay, near the memory, it could happen. Block it, bring that. Try to create as much as less disturbance for the standard cell to work through. You understood? So placement. So this pen density will look at. Then routing. You will enable routing congestion. You are seeing congestion at a place where there is no cell density. What is the problem? That means a lot of nets. How do you, if cell density is clean, pin density is clean, but still you have a place, you have a routing density, routing congestion. How will you resolve that? What is the reason? No, that's probably the least of the problem. Yeah, why it should happen in the same area? Okay. That means the module, this module and that module is trying to communicate. Okay, that means there is a problem with your floor plan, with your module. You have to adjust. Yes, you have to adjust that this module may have to shift closer. So this is the way you will look at your, yeah. You look at how the feedbacks are coming, right? And then see why this problem is essentially happening. Okay, you can do route guide, push this, you may see that this is happening, but it's only happening in M1. This is what you can look at, right? It may be happening. So push that. If it's only seeing, you have like 5, 6 layers, but this routing is happening in M1 only because that's a tightened timing it's trying to do. You add like M1 density, 60%, push that route to M3, M5, like that. So if it is in all the horizontal layers, all the vertical layers, then it's a different equation. Okay. So this is where it comes, whether it is horizontal congestion. If it's a vertical congestion, you have to look at modules like this. If it's horizontal congestion, you have to look at modules like this. If it's only one metal layer, then you look at how you push those routes to higher metal layer or from higher metal layer to lower metal layer. That's how you have to actually start analyzing where I need to actually do, whether I need to use route guide or I need to use, rechange my floor plan, or You know why this is doing? You understood?
While doing placement only, we need to consider DRC as well, right? DRC. You need DRC while doing the placement students.
You need DRC. What is that?
Means, we need to consider DRCs also.
That I have already looked at, before placement, right? At floor plan stage, I have run. Here, one of the things is after doing placement, you can just take the database, post it in post CTS data, just route it by default. Just give a routing. Let that actually route. You don't have to do CTS and that. Just route and see whether DRCs is coming. Don't try to understand DRCs from a congestion point of view. That's not a good approach. You give a real routing, but
Sir,
you
sir,
may
actually-
not need to run CTS. Just do a
Sir-
dummy routing, dirty routing.
Sir,
It's called.
Sir, actually, Sridhar is telling what are the steps in place of it will do.
See, in place of what it will do is,
Initial placement
as I
and
said, right, course placement. Okay,
actually,
first it
they-
will do course placement. You have to understand the sequence. Course placement is step number one. Then second thing, what it will do is it is high fan out net synthesis. That's the next step. Okay, so it will do initial high fan out net synthesis. Then it will start working on DRV. DRV means, okay, first it will try to fix the tram, etc. So that is the whole, it won't look at timing initially. It will look at,
Transition between.
yes. So what is that, once it's done course placement, what it can do from a route optimization. So then, once it is doing, then it will go back to the congestion, then it will look at the
final
timing.
placement.
See,
and
this is the steps.
place out.
It will do after, in fact, actually, after the course placement, it will do scan chain optimization also. This guy is switching. Can I actually do scan chain reordering?
Reordering.
Because this guy is sitting there, so it will have to do scan chain reordering as a next step.
Scan.
And then do the high fan out net synthesis.
For HFNS, we need to scan.
It will do scan chain reorder. You can check, you can reorder that. Allow that. So then it can do, then it will go into timing loops, then it will do that, then it will do legalization. Then again, one more timing loop, one more condition analysis. This is the loop.
Totally 5 steps. Initially place, initial ERC, initial after, final place, final.
First three macro steps: course placement,
Legal. Course placement, legalization.
course placement, then
Scan chain.
basically HFN optimization, PC not, then legalization. These are the three macro steps. In detailed steps, it is course placement, then basically, scan chain reordering, then, you will look at, HFN. These are all internal to PC not. We can look at, what it happens there. Okay, then legalization, then it's an iteration over here. Okay. The iteration happens between PC not and legalization only. Doesn't go back to course placement. Once it's done, mostly course placement is done. Global placement is done. The rest of the global placement tries to work within this particular factors. Then you will see that after this, these cells are getting placed over here somewhere far away, means after course placement, hey, this is critical for my IO. This is actually causing me something. That is when you will give the initial feedback that I need actually, magnet placement. I need actually some net, net weights for this, right? So that's why you will start actually working and allow the tool more guidance. You have to make the tool work for your requirements, not you work for the tool. Okay, the tool is running, you go. It's like a horse wherever it will run wherever you want. Why you will tie the blind eye? You have to make sure it is running on the right track. So you have to allow the tool to run in the direction that you want to. Because they are going to ask you the question how you are converging, not the tool the question. Why the tool converts? Tool converts. It won't convert.
Whatever when we put some accordingly, it will.
The EDA guy will take, he will say, these guys, they are junk guys, they don't know. That guy won't know anything. Okay, he will sit somewhere. He's going to give, so the feedback from them will be. So you'll have to work. Real algorithm, something is not working. There is a real issue. I've given this, it is creating congestion, means you won't be able to solve. You'll say, yes, I will try this new version, try this version. One thing you have to be very clear is you have to ask what are the tool versions I'm supposed to use. You are using some junk version or something. And before you do placement, you should also ask whether there's this particular data model was used before. So if it has a previous design reference, use that reference. Use those scripts. Ask for it. Okay. After buffering, you should see then, even DRVs also, after high fan out net synthesis, if they ask what is the step, you will do buffering.
Sir, first time buffering, we are not.
What is that? What is
First
that?
upside we are.
First sizing of the cells. Okay. First, even before that, it is going to segregate the whole fixes into categories. If net length more than 2000, this is a category. That means you should not go for upsizing. You have to look at, that is why net lengths are important. You understand? That's what tool is also supposed to do. You have to guide. Only when the net lengths are 100, then only you will look at sizing. Okay. Then if that does not work, you will look at buffering. So you'll have to break the net. Look at where are the long nets. Okay. Break. There, if you are going upsizing, you will put this big cell. It won't solve the problem, right? Upsizing, yes, but net lengths, which are the ones? So that's the category of DM. You understand? These are the things that you should track when you're looking at log file. Because tool is doing automatic, whether what is doing, how it is doing. You wouldn't observe, oh, that is running something.
Placement only it will take 3 days. 3 days.
You should expect the placement to complete overnight.
Overnight.
Yeah, sometimes it takes more than 2 days or 3 days. That is the expected data. Then the problem is, then you have to intermediate dump the data so that you can analyze something. After post placement, you analyze. After this one, you see AMD will run on slow machine. See, some things it's taking 2-3 days. It's a critical block. Ask for a bigger machine. See, physical design is not just about you designing. It has multiple connotations, how you have done your flow plan. It's about the tool. It's about the machines. So it's a resource intensive. The problem could be because of machines. The wall time, wait time is more. Okay, or license are not enough, or your tools are not doing the right thing. Problems you should exactly navigate. You should give all this to. Machine is bad. I'm not getting this. Every time we are hungry, engineers will say, I want best machine. Give me. What happens? You should deserve it. You will only deserve when you are doing the job. Then they will give you. The best engineers will get the best resources. By default, that's how managers are biased. They are biased like that. Unlike parents, no? What parents will do? The weakest child only she will try to take care. But the managers are not parents. They will say, weakest child, kick out. Kick him. Get out. Best engineer, so you need good resources. Yes, I will give you everything. So this is the point. You don't try to take your managers to be your parents. They are not. Your workhorses. You'll have to gain their attention. Okay. Understand this. Okay, you have to make the tool run to your competency. Okay, you understood? What are the other questions in placement?
Sir, how exactly the standard cell placement will happen in placement? How, what is the technology the tool will take care?
I've
Means
already
what?
discussed, man, Monte
Yeah.
Carlo technique, quadratic placement, I can go on, if I talk about algorithms, then, you can do, that's a research for you, you can think about it. But as I said, right, it's a divide and conquer approach. Basically, how you break the whole design and
yes.
see. As I
It
told
will-
you, the first thing for it is to
Yes,
bring
it
down
will
the
do
net.
global. Yes, it will do global.
Okay, you have to
routing.
understand
Yes,
the
exactly.
tools.
Divide and rule.
It wants
Yeah.
to reduce the net length. That's its first objective.
Yes. Yes,
Then
correct.
it wants to reduce whatever it can and then try to meet your constraints.
No, that is correct, sir. I can understand that one. I have got it, what you told. But the tool, how the hierarchy it will get means, yes, exactly. It will first mainly look at the routing stage. Is that's
No.
correct?
What do you mean by hierarchy? I mean, if you can explain, then I'll.
Means there will be different hierarchy cells. It will in a standard cell.
Different hierarchy means?
Different names, we have different families of macros will be. Different families will be.
Families of macros.
Yes.
Like 4 to 5 macro memories will be kept one family. 4 to 5, another 4 to 5 will be kept one family.
No, that is module. I've already discussed,
Module
right?
placement.
Hierarchy module.
Hierarchy.
No, that is, what is that? I think his question is different. Satish, what is that?
Uh, just a minute,
Nin
sir. I'll share-
ಕನ್ನಡದಲ್ಲೇ ಹೇಳಪ್ಪ.
1 second, sir. I'll share my screen. Just a minute. So my question is, sir,
Yes, go ahead.
yeah, as you told, it will do global routing. Means it will go to divide the global row cells with a percentage of some 60% of 50% of that to place the Microsoft cell. But my question is, how that tool will come to know that some cell has to place here only this particular region.
Okay, how the tool will decide whether the cell has to be placed in that particular region only?
Yes.
The tool doesn't know. Okay, because you have not provided any constraint. The way tool has actually done is, as I told you, right? It will look at, which is the optimized position for that cell so that the route length is minimal. The first way is it will place half the cells here, half the cells on the right side, half the cells on the left side. And it will do, the nets are already connected, right? Net list. It will compute how many, what's the total net length? Then it will say, okay, if I move this cell from this axis to this one, will my net length come down? Okay, because there are other net connected. No. If yes, then move the cell. If no, keep the cell. Next, that's the question. Move it.
Okay.
Ask the question, logic question, net length reduced. Answer is yes, move it. Okay, fine. Net length not reduced, keep it. Net length increase, keep it. Okay, then move to the next one. Should I move this? Yes, no,
Got it.
like that. Which are my modules? Which are my hierarchies? Where should I optimize? So that's the way it does its own work. Yes. You
Got it.
move, compute, move, compute,
Okay, got it, sir.
random. You understood?
Yes, sir, got it.
Hello, Ravi sir.
Yes, Suryavel.
Yeah, sir. I have a few doubts on the low power implications during placement stage. So
Yes.
how does it? Yeah, can you please share something?
Okay, low power implementation for at placement stage, right? So good. So now from a low power point of view, let us say you have a shut off always on domain. Okay, always on domain, you are not actually see one thing is there's a power route which is always on. Okay, and that is supposed to continue. So the standard cell is everywhere the path. Let me draw it for you so that you know you can understand what I am actually talking about.
Yes.
Okay, for example, the first thing I look at is let us talk about power shut off. Isolated view, you know, multi voltage power shut off. So let's say give you an example. Okay, so this is the block, and here I have actually one small area where my always on cells are sitting. Okay, and let us say this is the sorry. This is the circuit row, standard cell. Now, one thing you have to be very clear. This is your always on power, this is your shut off block. Or this is your always on, this is your shut off, right? Now, what you are doing is, this power is moving from VDD to this one. Here, there are 2-3 different techniques. In AMD versus other flows, I will tell you. Here, this is supposed to break, not connect to this particular guy, but connect to only always on power strip. But in AMD flow, you'll add what is called a breaker cell.
Breakers.
This breaker cell, no, this is a cell. What it will do is it will disconnect this power domain with this power domain. It won't have that VDD connection there. It is isolating. So this one, after this, it will place the standard cell. It will go and actually place anything because this is all connected to always on. This one is a, so it's called breaker cell. Just like you use on the IO's breaker cell. So here it can use. And then, you know, this will get actually disconnected.
Both sides will breakers.
Yeah, both sides is required. Because this is again another termination point, no? So it's required like this. Okay. The other part is you have another methodology. This one, this cell won't connect, this circuit row won't touch to anything because this VDD gets connected to the top, whichever from M12 it has to drop down. It has to connect to that VSS because all these standard cells have to connect to one particular guy, right? So you'll have to work out techniques like that because the VSS, the power will not come from M1. In that particular stuff, the library will not have M1 power rail for the always on cell. In this AMD always on cell will have M1 power rail. But if it's M1 power rail, this circuit row has to have a breaker cell. For the always on.
This one also amount, but this is not connected to these things.
Yes, because this power is broken over here. This is a complete always on power. So in the case of another methodology, the always on cell will not have M1 power rail, VDD VSS will not be there. That will be a pin. The power pin will be there, like inside the cell. Okay. Another, sorry. Okay. So another small power pin will be there. So this is the one which has to connect to the always on. M6 direct wire drop has to happen to this. This won't have VDD, VSS. VSS may be there, but VDD will not be there.
But these rails will be M1 only, right?
M1.
M1
This
only,
one will not sit because this won't connect only. Because there won't be M1 pin over here for this to tap like this. This will be double height again.
Okay.
Okay, you have to understand. This whole technique is very important. So the legalization is this one won't have VDD because it's not supposed to, because this one would have got hooked to your secondary power line. Okay, let me add more color to you, just to give you for example. Okay, let us say this is your M6 metal layer, right? I'm only drawing VDD. Okay, VSS, don't worry about it. Okay, this is your M12 VDD.
This is not circuit side, right?
This is not circuit height. I'm only drawing M12. Okay. And there is this green, which is, let's say this red is all 1.2 volt. Oh, sorry, everything is a single voltage, but it's a shut off case over here. Shut off case means this one should get. So the secondary power line is I'm depicting by green. Okay. The connection between red and green is decided by your you know, power gator. There's a power gator cell sitting. That guy will decide whether I have to short this or not, because this power gator will have connection to this one wire, and this one will be output, which will actually connect to this rail. Okay. Only the switch, whether it has to be turned on or off. All this circuit flow will get connected to green only. All the mesh will be between green and this particular M1 metal. It won't be between M12. M12 to this green should not have any connection. If it is there, it will be a short. This is a separate power domain. This is a separate power domain. You understood? Okay. Only the power gator will have two domains connections, but rest of it will be like this. All your M1 should connect only to this. In the methodology, where we are talking about not non-AMD, where I'm not adding any breaker cell. Okay, so all your, and this particular always on cell will be double height without this M1 rail or something like that. So what it will do is it will have this pin, which is like something like green. This one has to connect to the green. Okay. Green red mesh. This one has to connect to the red mesh on. Directly wire drop from red or route it from red to this, like that. Separate. Always on power only it has to connect. The cell will only derive the power from that always on power. It's not supposed to connect to this green. You understood? But when you have actually cells spread in a particular region, you can add, like in AMD flow, breaker cell either side, everything M1 connected, but here you will have always on power supply. It can move. Okay, always on connection, and then this breaker cell. Even if you have one cell, which is BS, which is always on, either side of it, you need to have breaker cell. You understood?
Yes, sir. Yes.
Okay. The rest of it I have discussed in the floor plan, right? You have to place your isolation at the corners, level shifter cells. You have to place near to the pins, right?
Yes.
And make sure they are properly aligned, everything. The level shifter isolation, all this you should try and control it manually and fix their placement. Macro should be fixed before you are running your placement, including all the special cells. They should be placed, hand placed, fix it. Don't allow the tool to place wherever it is required. No, not allow. You understand? Only the always on buffering, always on that and all tool will take care. That's supposed to be clear. But isolation, clamp cell, level shifter, macros, everything is manual. Okay.
Yes.
Any other question?
Mainly we are focusing DRS to fix the timing,
Congestion.
but for meeting timing.
For meeting timing, no. For
Only
meeting
data
time,
path we are optimizing.
data path we are optimizing. Okay. Here are we placing the cells closer, right? The first thing is trying to bind, right? Or trying to give that weight higher, net weight without bound. You are trying, if you put net weight, all the cells between those wedge to wedge will come and place together very closely. Okay, you can look at, so many options for the placement for the timing related stuff. You have magnet placement. You have actually net weight. You have bounds. Okay, you have path grouping, so many options. For congestion alleviation, what all options you have? Okay, floor plan, first split the module, give density screen. Okay, which is partial blockage, then you can give module, uh, density, cell padding, okay, route guides, all these are options. And again, from a tool perspective, for timing, you can give timing effort high, buffering, low effort, you can give a lot of options for the tool. Okay, when it's running place off to piece enough. Similarly, for congestion effort high, uh, reduce the buffer count, look at using of low complex cells. Right? Those are all options for you to help condition happen. Hello? Training already, See, good question. So what's a good deal is you have a uncertainty, which you have budgeted only for clock skew. Let's say clock skew budget in your timing is 50 picosecond or 100 picosecond. Okay, you can look at a budget, okay, of if the clock skew is set for 50, setup violation up to -100, that is double the clock speed. Yeah. So skew, double the skew can be the maximum range. That means skew can be that, this is assuming it's a worst path. If I have moved 50 picosecond, that means I have given 50 picosecond to the other side. It has got 50 picosecond extra. So 2x, the skew value is the maximum violation you should allow in your placement switch. But my recommendation is try to get it to 0 along with the skew because you may have something to play with. But up to 2x the skew value, you can allow the violation to move to the next stage. You understood the rationale behind 2x? Correct. It will go to the other side, right? It is a positive skew for us. The skew by definition is negative. So it can have a positive skew. It may be able to meet because when it's doing CTS, it will do. You're doing concurrent timing, it can give that skew to this particular point. That's the assumption. Any other question? Running out of time. Play CTS. We have now it's 3:40. Okay. What all the checks that you will do post placement? Your congestion should be clean. Okay. Congestion means the congestion score should be less than 0.5. Okay. Overflows should not exist. Legalization should be clean. You should not have non-legalized cell. That's the first thing. If you have a legalization problem, just go. Okay. So legalization should not be without before you looking at condition also legalization you have to look. Legalization should be clean. Then basically your cell density, pin density, okay, should be good. Placement density should be blue. Because if you have even yellow, that means issue cannot be possible there. If you have timing violation, how will you fix? Right? You have to analyze these things. Okay, expect like this. Okay, this is what I do. Routing congestion should be clean. Okay, there should not be red spots. Right? At routing level, yellow is okay. Yellow, sprinkles of yellow. If you have a bunch of yellow, hard patch of yellow, that is a problem. It cannot route because crosstalk will come. Yellow means 100% utilized. 100% is always problem. When you're routing, crosstalk, everything is screwed. Patches of yellow. I mean, small dots of yellow is okay. Sprinkle green, good. Okay, yellow patch. If you have a big chunk, it's a problem. It won't route. Non-routable. Go back. Okay, even if your condition score is good, your things are same, but you have a yellow patch, not acceptable. Okay, overflow is 0. Even then you have a yellow patch, not acceptable. Patch, sprinkles, yes, somewhere. If you have a doubt, take that database, put it because CTS cells are not been added. Clock cells have not been added at that stage, right? It will come and it will go. So just do a dirty route. Take that database, put it in the post CTS, set up, run it. Give one dirty route, you will see ARC will show anything you can find. Okay.
Yes, sir.
Any other question?
Sir, one
5 more minutes for placement. That's all. Huh?
Sir, I just need one more clarification.
Go ahead.
Yeah, sir, is it I mean, if at all there is a positive slack after setup fixes, shall
If
what are
at
the
all
case,
there is a possible
I mean, there is no positive slack setup.
slack. Okay.
Yeah.
Hmm.
What are the cases where even without fixing the setup, we can proceed to the CT stage?
Okay. So that means, if I understand your question, there's no possibility of improving the slack.
Yes.
Is that the question?
Yeah. Even
Violation is high. What is the possibility? Violation is present, but can I move to the CTS? What are the possibilities? One question I've already answered. If the slack is within 2x of the skew value, you proceed. Okay. If the slack is more than that, okay, one thing you should analyze is whether the 2 stages or 3 stages you have actually useful skew possibility. Okay, so let's say, but definitely if the violation is more than 50% the clock period, you should not even think about it.
okay.
You should
Right.
look at the histogram of paths. See, one
Right.
of the things when you are looking at timing, it's very crucial. Huh? Timing
Yeah.
report, which all the reports you will look at?
The
Generally, you
rescue.
will open the setup timing report and look at it. No,
We should explore the paths. The
that's
rescue.
also important report. Okay,
Yeah.
but that's not the key point. You have to look at the histogram of your timing.
Yeah.
Okay, report QR. Look at the QR report. How that is actually what it is saying. If everything is close to your critical path, then you are screwed. Only some paths are supposed to be closed. So you have to look at histogram of your paths. What is the slack between -100 to +100? If you are saying there are 1 or 2 paths which is violating by 1 nanosecond, let us say your frequency is 1 gigahertz at 1 beat. Okay, what should I do? Can I do multi-cycle for that? Okay, so you have to check with them. That ideally should have come if there is such a violation before only, but you can check 1 or 2 parts which are actually happened, whether it is over buffering or something like that, you can look at it. If you are having, like few parts only outside the core of this QS, and that can be optimized, let's say less than 0.1%. Less than 0.1% is outside 0.01, I would say, but 0.1, let us assume some number. Less than 0.1% is outside your, actually, let's say you have a 50,000 flops, 50K flops in the design. 0.1% of that is what? 50 flops, right? 50K flops means 0.1% is 50 flops are violating. More than this means then it is okay. I can control something. If it is violating more than 100 PS, some 200 PS or 300 PS, I can still look at something to do with that. Okay, I can do some special optimization for that if it is sitting in the same module, single module. If it's in different modules, then I can look at more options for that. Give path, give that group path for those options, or look at what you have to do for that. But post CTS you can still fix some value because you can change that to LVT or certain options. Okay, if you are thinking there's a VT swap option available, you can move forward. If you are having the option of actually using higher drive cells, or you can change, okay, something like that, then you can move. But more than 0.1%, if it's violating beyond this, then you have to stick with the place. You have to resolve that. Okay. I have to move to the CTS.
Yes.
One last question I'll allow. If there is one last. I don't think we have time. The CTS is a big chapter. I mean, a lot of things, people don't know. Basically, CTS taking tool way to, the whole process, right? CTS now.
Still.
Yeah. So tell me,
Sir, one question.
final question, one question, last question is going to be.
Actually, we know I actually asked Sridhar, Pooja and Sarish out, but I have to conclude that one weekend period. Why we are not checking hold at the, why we are not giving preference to hold at placement stage?
Okay. So I told you, hold is a problem of skill. I told you first thing before you go to placement itself, you have to check one hold. You're not supposed to have violation. You're not supposed to have hold violation before placement. Okay. You can have 10 picosecond, 15 picosecond violation. It's okay. It might be a constant. If the hold violation says that it's more than half a cycle, then there's a problem with your constant. Okay. Hold is a problem of your skew, which comes in the picture. That's the reason why you are not checking hold in placement. Before that, number one. Number two, why you are not checking hold in placement is your focus is on the setup corner, which is your worst for the maximum delay. Your hold comes for the fast corner when the delays of the cells are minimal.
Yeah.
You are not checking. If you enable that corner for that, it will add more confusion. You understand? Okay, you are not checking fast corners in placement.
Sir,
Hello?
one more point.
I'm in training like
Sorry, sir?
that. இது available இது மட்டும் போடு வேற எதுவும் போடாது. Kindly let us know the rate would work. Kindly share us the schedule and also put that let us know the rate feasibility also. Okay, done. Shall we move to the CTS?
Sir,
Sorry,
one-
CTS is where good amount of time is required, but I have only 1 hour. It's 3:50. So we will discuss anyway. We have opportunity to discuss. We will discuss later, but for the interviewers, there is a preference for you first to ask first set of questions to me. Okay. Anyway, so yeah, CTS. What are the goals of CTS? How do you analyze? As I told you, right? Before you look at anything, is before you in placement only, you have to cover for all the things, NDRs, etc. in CTS. What are the goals of CTS? Yeah, minimum insertion delay. Skew again has two contexts, global skew, local skew. There's all the third one called boundary skew. We'll discuss about that. Okay, but global skew, local skew is one thing. Okay, then
Minimal DRVs.
minimal DRVs. Okay. Okay. What else? Okay. First, let us say you have, you know, the utilization at the post CTS. CTS again has three branches, right? Just the clock tree construction. Then there is a post CTS setup. Then there is a post CTS hold. Right? So three steps. Whether you have to do post CTS hold or not, we will discuss about. But these are the three steps of clock. Clock construction, pure CTS is about clock construction, where the objective is not of, doing your timing fix. The objective is skew balance, minimum insertion delay, minimum number of
Buffer insertions.
The balance.
but levels of buffers, that's also important. Okay, so you cannot have, if you have more number of buffers in one level. Okay, level means that also would cause you dynamic power. So the buffer levels also are supposed to be spread. See, CTS again has multiple techniques. Okay, structured clock tree buffer. You can enable any algorithm depending on what is available. Okay, generally cluster and H3 balance is what you have used. Okay, I have already spoken about CTS exceptions. Right, exclude pin, what you have to do, stop pin, what you have to do. So CTS construction can be a single shot or can have multiple parts to CTS construction. Okay, so that is you are building the initial clock tree, then you are allowing, because one thing, first, which corner should you use for CTS?
The first corner.
No, the worst corner.
Because we are mainly preferring hold.
Mine preference is hold.
So.
The C best.
See, this again is a dilemma.
Typical corner.
There's not one good answer, but the best answer is still this. Okay. You focus on your setup because that's your control. Run your CTS on the worst, but also check CTS on the best corner. If your skew variation is too big between the setup, because generally you should understand the cell delay between the worst corner to best corner should scale roughly 2.5. It should not be more than 3. But there will be some cells like delay cells, etc., which can scale up to 6x. That means delay of the cell, which is 100 picosecond, 10 picosecond in the fast corner, can become 100 picosecond in the slow corner. If you are using such kind of cell, the problem is if you create both the setup as well as hold in the same path, how will you fix that? Problematic. So the scaling should not be more than 2.5 to 3x. This is the expectation. If you have anything outside this, then those are cells which you should avoid using. Can happen. Should be clear. Generally 2x is what you should expect, but more than that, it's possible. Okay. So CTS you will run at the worst corner. You will, for the CTS, ideally you have to create a separate constraint. Okay, like MMMC, you are running MMMC CTS. It's a problematic. First you run the functional mode CTS, then you append the test mode CTS. Okay, because first the functional pass, because the test, once the functional part clock tree is built, the test part clock tree, whatever test connections has to happen, it will only add additional small route. So otherwise, what will happen? Another test, if you build for the test clock tree, then it will be a problematic. So you have to run CTS first for the func mode. Placement also, how you will run? You will run multi-mode, multi-corner whenever you are doing MMMC. You can run func mode, then you can then it will run test mode, etc. So same thing, you will build the CTS first for the func mode, then you will append with the test mode. You build some smaller trees. You build the main tree, the main root. If you want to control, you can build clock tree. You can do single point CTS, multi-point CTS. Okay, CTS is a big topic. Okay, if you have a mesh, clock tree mesh, where you are actually doing, mesh is a multi-point CTS. The problem is mesh will have more area. The routing clock power will be high, but skew will be very, very less. Mesh is, it is intersecting clock tree at the horizontal, this one, so it will short. So that won't add to your insertion delay because it is short. Your insertion delay in the mesh will be the least. Okay, but the power consumption will be high. Because to drive that mesh, you need special buffer. You use a normal buffer to drive, even if you put 10 buffers also, you want 15 damage. 28 standard buffer will be that mesh buffers. You have to be clear about that particular part. So if you are using mesh, the mesh should be driven only by mesh buffers. Not just any clock tree cell, no. Okay. Yeah, you can call that as Tmax cell. You are using AMD terminology, Tmax thing, and then Tmax. So there is one which will drive the mesh. The second one which is going to take the current from the mesh. The mesh, which is actually from there where you are tapping also, that is like a mesh buffer. Okay. If you put a normal buffer, that will actually have a problem of, because high current will flow into that and you will end up actually having EM violation of that cell. So the receiver cell should be a mesh buffer so that, they will take them. Driver should be Tmax. Okay, these are all standard rules, how we are going to deal with it. Okay. The clock tree, once you are giving, you have to ensure that the DRB is set for the clock. Okay. Clock ideally 10% of your transition. That's what we should aim for, 8 to 12%. If it is a 70-30, 40% budget. Otherwise, should not definitely not exceed 20%. Okay, 20% is not about 12.5% is, I would say, is reasonable enough. Okay. So that should be a transition limit for your clock tree. And you have to use keep the I mean for the set of standard, right? You set max transition to 100 picoseconds. That is if you are running at 2 gigahertz or 3 gigahertz also. 60-70 picoseconds would be good, 12.5%. Because if you are typing the transition too much, if you are keeping like, okay, why not 2% transition? What will happen? It will add a lot of clock buffers.
Pulse width violation.
What is the problem with transition on the clock? If
Pulse
clock
width
transition
violation.
is bad, sorry, what was the question? You had some question?
If the tran violation is there, they will end up with pulse width violation.
Yeah, pulse width is one thing. If your tran is there on your clock, your data path delays also will be more. This one will impact your setup time will be more. Your hold requirement will change. Because setup hold depends on your clock tran also. Your clock to queue delay will change. Clock to queue delay change means this transition, output transition will also change. So your clock transition will change the whole transition of your entire design. That's the problem. You understand? Your clock transition should be sharp. Second, your clock transition should be sharper than your data. Why? If your data transition is more, okay, data transition should be relatively weak. Because otherwise, what will happen? Your data will be aggressive. Your clock can be aggressive. If data becomes aggressive, then if you have crosstalk on your clock, your design quality will be right. Then you will have skew variation. Variations on the clock tree will be more. And variation would impact the yield to everything. Okay. Your clock should always be the aggressor. That should run fastest. Then your data.
In the point of cost. Why data should not be aggressive?
If data becomes aggressor to the clock, what will happen is it will impact clock crosstalk, clock transition will increase or decrease, no? If clock transition becomes variation, all the data also will vary. It will impact the whole design. You won't be able to get a good control on your CTS. That is why clock buffers are big. What is the specialty of clock buffer?
It is have
Equal rise time and
equal
fall
fall
time, that is one.
Less transition time than the normal.
Yeah, one. Third important thing is it is characterized better. That means its variation across corners is controlled. Unlike the data, the variation across corners for the data is not characterized as well. It's not required. Because if you were to do, then your data cells will become bulky. Why you should not use clock cells in the data bar?
We can use,
But these clock buffers and emitters takes more area than the normal buffer, which
Exactly,
is unnecessary,
exactly. It
yes,
will consume more area, not required.
not required.
Okay.
and also clock buffers is an LVT cells which are using, it will, the leakage will be more.
So clock, when you are building clock tree, you should not mix too many VTs. Should be of single VT. Because you have to minimize all the variation in the CTS. It can be any VT, don't use HVT because then your transition will be bad. It will become weaker. Keep it as the maximum aggressor. Your idea is clock tree has to be aggressor, no. In your design, if you are using LVT, HVT, SVT, everything, then your clock tree also should be LVT. If you are using SVT, LVT, then you can use a clock tree with SVT. This is the idea.
Yes. And one more
Or you
reason,
have to specifically hand fix some LVT or some specific parts.
and one more reason why we will not use in data path the clock buffers means because the clock is high switching activity, switching cell. The power consumption is too high.
Yeah, see, but you're true, but it's switching fast. Dynamic clock, because the transition is big, it will switch fast, but the leakage, that's a problem. It's basically the area is the biggest problem. Why you should not use your clock in the data. Okay, one or two escapes, it is okay. But they will not allow data path into your clock cell because what happens the variation, right? The problem is of variation. So when you are doing clock tree, you have to analyze both your Q at the while you are doing your clock tree in the worst bus low corner. Should also check for fast stuff. How your skew variation is big. Why? Because the skew can be because of net delay or because of cell delay. Because instead of some places you have 5 levels, but some place you have actually only 2 levels. But the delay is same because there's a net length. Net length doesn't scale equally between the slow corner and fast corner. Net delay won't change like 3x. Net delay may be changing by 30%, 40% between fast corner and slow corner. Whereas cell delay would change. That's why you would see in the fast corner the skew is big. Then you'll have to go back and change the levels. So don't just go by skew at the fast slow corner. You have to look at that whether the levels of logic skew at the fast corner is also important. Why? Where that is so, you will draw the Gaussian curve of all your insertion delay at the fast corner. Get that. You get the point? Okay. So, and clock tree, what is a good NDR to use? Is it good to use double width, double spacing? Or should you use single width, double spacing? Or should you use a shielded? clock tree? Which is good one?
Double width, double spacing.
Double with the double space.
Why double width, double space is good?
You can say,
And avoid
we will avoid crosstalk and diagonal both.
I'll tell you the counter of it. Yes. First, let's say if you're using double width of clock tree, that means the crosstalk on its effect will be less because it's a thick. First thing why you are using double width is electromagnetic EM will be stronger. Okay, bigger buffer you can use, etc. The problem means you are using double width means cap will be high. Your dynamic power consumption will become more. Your clock tree is your biggest route in your design. You are using double width congestion. Right? Yeah, it's congestion, it's power, and because you are using double width means the capacitance is more means you have to use bigger buffers. The delay, the insertion delay will increase if you are using double width.
Simply with the double space.
You understood? Okay. Single width, double space is a good option. The problem is single width when you are using, okay, it can add, it is susceptible definitely for EM. Okay. But that's an option that you can actually still try and use. Double spacing is must.
pretty much based on detail.
Correct. So you want to aim for a critical net, like key net which is crossing. There you try to use shielding. Shielding. What is the problem with shielding? Shielding, if you are using, what is shielding? Shielding means either side you will use ground
Ground
or
rate,
VDD. This is the one preferred to use. Right?
ground.
If you are adding ground means, that means you are adding capacitance, ground cap. Yes, it will avoid any crosstalk. You are added shielded means there's no way crosstalk can happen on that. Okay. Clock tree is shielded. But the problem is the overall capacitance and insertion of your clock tree will be small. If you are adding shield, you have to add more buffers. Clock power. This is the thing. So you'll do a trade-off between timing, area. Principally, performance will be good, but you will have to do a trade-off between routability and power. This is the key problem. Okay. And around the clock buffer, you place decap. Okay, so that it's less susceptible for dynamic. Because it may be crucial for some things, depends. So these are all methodology. Okay.
So one more thing.
How you will fix transition on the clock tree? Should not try to do buffering for a clock tree. Once you have built the clock tree to fix transition. You should do upsizing or downsizing more, or you have to structure that properly. Okay, buffering the clock tree is the last option because you will change the levels.
Sir, one more thing. Sir, one more question.
Go ahead.
Sir,
Talk louder, come closer to the net. Not
Sir, one more question. What the thing means, the in CTS, the main target is latency and skew. And we will be getting a target latency and a target skew. Can I know how we will decide that target latency and target skew?
Yes. Target latency, how you'll decide is on the size of the block. Let us say the size is 1 mm by 1 mm. The worst case it has to travel is 2 mm for a clock tape. That's the distance. For 2 mm, how many buffers it's supposed to travel? That's what you are actually going to compute. And this is the target latency you are actually trying to make between different blocks because this is interclock balancing, right? This latency has to be balanced with some other block other side. That's when the interface timing will be balanced. If in one block you have 4 nanosecond, if in this block you have 2 nanosecond, that means you have a 2 nanosecond skew between these two blocks now. How will the interface timing between these two balance? Then you will have to add externally 2 nanosecond for this. You can add externally, but these are the things that you have to be very clear. Okay. CTS actually there's a lot of things to talk. Lot of things. Okay. I'll see what all I can talk because it will be overfeed. The complex topic also. So one thing what you have to look at is to minimize first thing before you do CTS, before you touch CTS, what you have to do is look at all the mux placement manually. Look at your clock tree structure. My mux is supposed to place over here. This is the source. Here is what you have to hand place those cells before you do your placement also. Or if you have done your placement by any mistake, you have to move the cell accordingly to try and actually make sure things are working. Hand place the mux, hand place possible hand place the clock gator, but otherwise it is okay. Okay, because you are seeing that because of clock gating. Okay, CTS again, how this works? What is the algorithm? It will place the CTS cells for that. Then it will do cloning of your clock gating to try and actually match your stuff. So if you are seeing that this particular clock gator is connected to 300 flops. One set is sitting there, another set is sitting over here. To balance that, to do buffering will be very difficult. So you clone that particular clock gating so that this module where it has to sit, you are actually keeping that clone like that. So you have to look at your distribution of your clock tree properly. You enable all your flops, look at where each module is there, which one clock gating, all these checks you have to do. Somebody has to sit on that, especially muxes. Mux should be on the line of eyesight. It's called eyesight. What is eyesight? Eyesight is basically in a cone, nice cone manner. Internally to the cone, the mux should sit. The mux is sitting outside the cone. That means cone means there are set of flops. Okay, that is called the mouth of the cone. Then there is a start point of your clock pin, which is somewhere sitting, right? The mouth of the cone and this one is the way you are looking. And you have to see that mux is actually sitting within that cone span. It's sitting somewhere far else, then you will see lot detouring. That means the mux placement has not happened.
Sir, can you elaborate in design? I mean, by writing the
Yeah, I'll show you.
drawing.
So let us say here is your okay. This is the block. Let's say one set of logic, all the flops of that particular logic are sitting here. Okay. And here is your clock pin. Just let me illustrate. Okay. Now, the expectation is between the tangents between these two, right? So this is called line of sight. Okay. So the mux should sit anywhere between this line of sight. If the mux is sitting somewhere far off like this, or mux is sitting here, then this is like deviation. Your clock tree won't be of good quality. This mux should actually sit over here. Then what will happen? The construction will happen in a good manner to get your minimal insertion.
However, clock shouldn't be go away from this side.
Correct. It should not go like this and all.
Zigzag forms. And offset only.
Correct. Then what it will do? It will construct like this, right? So then you will get a good clock tree. Okay. So similar, something like this. So you'll get a good clock tree within the line of sight. So you have to make sure the clock muxes, the clock replacement cells are all properly taken care, so that this one logic is actually in good control scenario. You understood? Then it could happen that all these muxes, should I place it at the close to the clock pin, or should I place close to the logic? If you are saying that this is also another question, right? So let us say this is the clock tree, and this clock tree has this is one clock mux, this is the other clock mux. This is feeding some other logic here. This is feeding some other logic here. If I place everything close by this one and allow, then what will happen is you see your trying to build a long net without actually proper control. So place these particular guys somewhere in between. Okay, so that this net will spread properly. Okay, because this one will have 2-3 nets coming out of it. Okay. This clock buffer, this one, you have to really construct. I can show you with some things. Okay. So do a good job of your clock tree placement. I can
So thi-
explain next session more in detail. So, but have this because I want some things to stick in your mind. Okay. And the next part is, you know, this particular path is called the stem of the tree. Okay. And this one, maybe you don't want any crosstalk over here. If you want, you can add just for that particular net, you can add it like a shielded net. Okay. But from your clock getting to your flop connection, that can be, that's called leaf net. Okay, root net, leaf net, middle net, right, stem, all these are certain. See, leaf, it's okay if it violates your NDR. Okay, close to it, you may not have spacing, short net. So try and keep the clock getting as close to the destination as possible. Okay, that means your clock gating should be close to your logic of the clock. That should not sit too far away. You understand? I'll explain why at a later stage. Okay, but clock gating should sit close to the flop. Okay, your, then what would happen is basically once this particular guy is switched off. Okay, if you are keeping clock getting away from too far away, all this would impact on the crosstalk. Glitch will be high. Okay. Some people prefer to keep over here so that long net clock is switched off. Then you will save power. But there are counter problems to that. So ideally, I would suggest keep the clock getting close to your cell flops where they are actually sitting, somewhere in that cone. Same thing, cone, eye of sight. But it should be closer to that cone, not towards the source of them. Okay. And if you are seeing that, one bunch over here, one bunch over here, clock getting max fan out, you keep it like 32, same standard. If it is more than that, you clone the clock. Okay, because driving more than that means would be a problem because your clock gate delay will be high. Then you won't be able to do your skewing or anything that is required and you can end up a problem. Okay, check that out. Okay. So at the end of the clock, you have to verify CTS. Insertion delay should be good. And levels of large clock should be good. The variation between fast corner and slow corner should be good. You have to check. This is what you have to say when you are in the interview. Then you have to say that, there should not be any clock DRBs. The local skew should be good. Global skew should be good. Okay, it can have some variation, but local skew must within like 50 picosecond. Global skew 2x of that is good. If global skew is varying a lot, means there's also another problem. Okay, we will talk. There could be a question why you don't care about global skew. You can say, yes, global skew is a problem because IO timing, etc., may impact or some logic to this one, but they may not have any interface. Global skew means this is an unrelated flop, this is an unrelated flop. They are getting different insertion delay. Only if they are different clock domains, then it is fine. For each clock domain, you have to actually make sure. Okay. Then if like a test logic, right? You have this is one functional clock, this is another functional clock. They are not related to each other. But in the scan mode, okay, in the scan mode, they can have interfaces. Then you should add lockup latches. Okay. to disconnect these two so that even if there is skew, you don't get hold violation. Half cycle path you will benefit, you will get. You understand? So you work on things like that. Okay. So I'll explain how the lockup latch everything, but you can use this works. We can use lockup latch. If
The
we have
lockup
used,
latch, sir, lockup latch will be inserted in a synthesis team, no? To fix the hold violation.
no, at CTS or before that also, while DFT get inserted, they will do.
For
Okay,
hold
but you
fixing.
can find if these two clocks are not related,
Mhm.
and then they are getting actually some paths, skew path means you ask the you can insert a lockup latch, you can inform the stuff, but once you are inserting a lockup latch, you will fail the
LEC.
formal verification. You can give rules to fix that, not a problem. You get that point?
Yes, sir. Sir, what about target skew, sir? I will come to know
Okay,
that
what is
value.
target skew? See, target skew, I said, right, a target skew, a good portion of that is, should not be more than 5% of your clock frequency. Clock period. Okay, 5 to 10% should be your max skew target. Okay, because more than that means, you are actually shrinking the area too much. I mean, timing path, it is causing a lot of problems for you. Okay, 5 to 10%. Because 5% of the queue anyway will come from jitter, 2.5 to, so they may allow 5% queue. Okay, you can say we should not exceed more than 10% of the clock.
Yes, sir. But usually till now I didn't saw that any block owners have been deciding that target skew.
No,
Like,
block owners don't decide. That's all we
Yeah.
decide, architects. Right?
Okay.
So we will tell you, but as block owners, you have to be aware. There's more, can I use? You can use useful skew.
Okay.
Hello?
Sir, one more thing. What about the CCD, sir? Concurrent
Yeah,
clock and data.
Sorry?
CCD, concurrent clock and data to optimize the skew.
No, that is CCD is for timing optimization, not for clock skew. Okay, post CTS concurrent data clock path is basically to use useful skew to optimize to fix the timing paths. Okay.
Okay.
By default, don't enable CCD.
After traditional CTS only, still we.
After traditional CTS, you have to enable now timing modes and check the timing. Okay, the timing is really bad. Why? Somewhere the screw must have screwed up or something. The cells have got displayed too much. So one of the things in post CTS you have to look at is the displacement. Okay, even in your placement also you have to check what is the average displacement, what is the max displacement. Time paths are moved the cell after during legalization, if some cells are thrown very far away, then there's a problem, there's a cell density issue. Similarly, in CTS also, displacement should not be too much. Okay, average should be less than 1 micron. Okay, maybe something like that. Okay, so for CTS, just enable the timing and check what has happened. You may see few paths here and there which has actually deviated, whose delay, some cell delays may have increased to 600, 700, that would have gone thrown up. Then first thing you do is legalize and see, run post CTS setup of the gun. But before you do that, you should check for setup timing just at the CTS level to check the quality. You should check whole timing also just after CTS to see how your variation between the max and min has actually happened. Cell delays. Now you should enable. First thing before CTS, you should enable, CTS you will run at worst case, then you should enable the fast corner. Now you will give a fast pass TLA plus 5. Okay, you will have to enable that and you will have to run those corners. You understood? Then you check whole timing at that. Then you run actually post CTS setup. Okay. Post CTS setup again, first thing you should do is you should not use data path optimization at that time. So post CTS setup, enable first clock skew, etc. for it to actually do something. Run CCD if required, if the violation is more, and let it optimize it in that. Then you can work on the data path optimization. Okay,
Sir, one more thing.
you
Coming
convert
to
the whole setup. Yeah.
yeah, coming to this insertion delay and latency. Actually, what is my thought means, I don't know whether it is correct or wrong. Please, if it is wrong, please correct me. Insertion delay is we will tell insertion delay when it is in CTS stage, when it's adding the buffers to the clock tree building. The latency will come picture when it is doing in optimization. Is it right? After
Both are
insertion-
same. I mean, see, insertion delay and latency are the same. Okay, the point is insertion delay when you are actually saying at CTS, it's the max insertion delay. You are just taking about the longest path. Okay, latency means for every flop, launch flop, whether it is launch or capture, its latency will be different, and you have to run timing post CTS in a propagated. Up to that, it will run in the ideal flop.
Yes.
After CTS, you will run in the propagated.
Oh, yes, that is the latency.
Okay, you have to move that.
Yes.
And then you have to understand that. Then you have to measure for the CTS again for the IO paths. Again, you will have to do adjust. Latency adjust you have to enable. Because without running latency adjust means what will happen is before in the ideal case, there's no CTS. So it will assume clock is coming same for launch and capture other side. But once this is there, you don't have an external path. Once you do adjust, whatever latency it is seeing on the launch side, it will add the same thing to the set output delay also. Then only it will do the check only for the data. This is the latency adjust. I spoke about boundary skew. I will talk about it later. Okay, now I will come. So look at this from this concept.
So one more thing.
No, yes.
Sir, by taking one example, just can you explain that how clock tree is balanced? Means there is one master clock and 5 generated clock. Now, how the clock tree is balanced now?
See, so this is supposed to be the clock pin, which is actually trying to connect to this, right? So let us say okay. The clock tree is balanced if there are level of buffers, right?
Means there is one master clock and 5 generated clock.
One master clock and 5 generated clock. Okay.
Yes.
So generated clock can be anything, but at the end, everything will be run as a master clock only. Okay, the output will be like that. Generated clock is more for a timing information point of view. But from a clock insertion, the source clock, everything will start from here. You can have a buffer over here, mux, output of the mux. Okay, here you may have defined generated clock. Okay. But the balance has to be seen from this point only.
Okay.
You'll start building the clock tree over here, generated clock, then you can build this route separately if you want. Or you build everything together.
So from one master clock, I'll go to connect to the mux like divided by 2. From there, I have generated one generated clock. From there, I wish to do the balancing, clock balancing for the register. Is it right, sir?
Sorry,
From master clock, I will be connecting to one clock gating and then it is connected to the one mux. From mux, again, it will generated the master, there is generated clock. From generated clock, again, it will build the clock tree to the left cells, registers.
yeah, see, how I would actually suggest is, first you build this route. You build this path. Don't touch it.
Okay.
Okay. Build, if possible, even the stem. Okay. If possible, between these two muxes, you can build whatever in the tree. Balance it. This clock tree, that's what you have to understand from a clock design. Clock tree diagram, right? You build this and then you allow the tool to construct the clock tree from these points. You go and balance. This is easy for you to build manually.
Okay.
Okay, because there are hardly some 10 nets you may have to construct. Okay, because then you will control these placements properly. You would balance these things and balance this, and then you allow the tool to construct all that leaf nets. Then it will balance smoothly. You'll have to define that this is another clock pin, this is another clock. Okay, clock 1, clock 2, clock 3, then it will build accordingly. But sometimes this can have overlap with this. Okay, if these two clocks are overlapping, then you take only one clock and construct it. So clock tree is a little complicated stuff. So people don't understand, they just give the tool. Tum karo yaar. Then it will do karo only. Won't be able to control.
So what are the advantages of using generator clocks? Why we are not using master clocks?
Okay. Why we need generated
Latency.
clock? That's the question, right? So the idea is some paths. Let's say one example of this path. There's a one part which has to run at 500 megahertz. There's another part which I don't want to run at 500. 250 megahertz is good enough for me. I am going to run this design at 250 megahertz. So I'm going to generate a clock. So divide by 2 from this for this to run at 250 megahertz. That's the way data will get optimized. If I try to run this at 500, I have to add those many flags, those many sort of stuff. It is not required for me. Because then my frequency increase, power also will increase. So I am supposed to run this design only at 250 megahertz. Then I will do a generative. Yes. If you are creating another PLL for that, then you will be completely delinking these things. They will never be in synchronous. They will become asynchronous.
Maintain that synchronous property.
Because these are synchronous paths.
Mainly the source latency is not calculated when the
way,
so latency, the source latency means when the report is generating like from
Yes.
generator clock to
source
reg.
latency, network
Source la-
latency.
Yeah, that is the main thing. So we need a generated clock.
Yeah. No, you need a generated clock. I have already explained because you have to run at a different frequency
Yes.
or divide by frequency or multiplied by frequency, whatever be the case, right? You need that, and that's why you are generating a clock for that. You understand?
Or in some generated clocks, we are observing that in that command divided by 1.
Yes.
What is the
So,
purpose of?
Yes. So this is also a good question. Why you are using generated clock when you are actually having a divide by option? See, that could be a dummy definition. Why you want is because this one you want to delink from some other clock. Because that one is also divided by 1, this one also divided by 1, but they are not talking to each other. You can build a separate unique clock tree. These two don't have any timing interface between them. That's why you are saying divide by 1 option.
Like cloning, we can do.
Something like that.
Difference between single point CPS and multi-point CPS.
Okay, single point CTS is you have only one clock point from where you have to build the entire clock, main clock. That means. Multi-point is you can have multiple sources from the top level, like mesh. I am supplying one more clock pin to this at the center, everywhere I can supply. That's called multi-point CTS. Then what you will do is the logic sitting closer to this, the flops will have to connect to this. This whole algorithm itself is different. This should not connect to something over here because if this cell were to this flop connects over there, insertion delay will be more. The reason you are doing multi-point CTS itself is to bring down the insertion delay.
There any chance to have both single point CTS and multi-point CTS in our design?
Yes, you can have a mixture of that. There could be one, see, main clock can be multi-point CTS. There will be some cluster clocks, small clocks, which can have single point CTS. You don't have to have multiple point of CTS for everything. Not required.
Based on requirement,
Because multi-point CTS becomes expensive because you have to build a clock mesh.
mesh clock or speed.
And you have to add that, that means you are actually creating, you are using condition, power, everything. The only advantage of multi-point CTS is the critical point is timing, right? You are going to get less delay variation time. Variations will be lower.
But our first preference is
But
single
power
point.
consumption,
First preference is single point CTS.
if it can meet your time. Because that's the least power consumption, least power hungry. In all high speed designs, MPCTS will be used. For the moment. Any other question?
Last time you asked one question regarding that word, but so many research I did, but I didn't get that answer. From experience percentage. After everything done manufacturing, gold violation is there. What will happen? You ask the question.
Okay. Okay. So this is a question, right? I told that, you have manufactured a chip. Right? You have manufactured a chip. There's a hold violation in the chip. That was the question I had asked. What will you do with the chip? The hold violation in the chip means what will you do with that? Will you throw it?
Because we just so much
Functional failure.
important time.
So what will you do? How will you use this? This was the question.
The
Okay,
function,
if there's a setup violation, you can run it at lesser frequency. If there's a hold violation, what will you do?
function failure.
You can use, huh?
Functional failure.
No, we can push and pull the
How
clock.
do you make it functional pass? That's the question, right?
No, we
You should-
cannot.
How will you
We
do
ca-
derating? Manufacture,
Manufacture.
manufacture.
Yeah,
What you
it-
can do, see, you cannot actually change the process, it is manufactured. Temperature, it depends on whatever it is, you cannot do anything. What you have in control is voltage. Okay, so what you can do is, you can bring down the voltage, you have done this design for 1 volt. At 1 volt, there's a volt failure. Okay, if I run it at 0.9 volt, what will happen? The cell delays will increase internally.
Yeah, world.
Cell delay increase when the volt bank gets fixed. I reduce the voltage, maybe my performance will go down. It may go down, I don't know. It may go down because it may be, it's okay, I can run it at a lower frequency, but my hold will get fixed. So the only control you have is the voltage.
Shut up violation, sir, we can reduce the frequency something and we can make it happen.
But for whole.
You can run, no, you can sell it to some customer who needs a lower frequency, right? But you have to, voltage is one option you can actually try and reduce, because this, you don't have to do anything with it. You supply a lesser voltage, that's all. You have to think 360-degree in a box, which are your controls, what you have to do, become an engineer. When you will move from clerks to engineers, I don't know. Why they have given you master degrees? Okay, so that's the key part. This stuff. Okay, what other questions you have? So this was in his mind, wow. Now you're asleep.
Sir, so many persons I have asked for.
Okay. Any other question before we move to the next stage?
So about clock tree exceptions, like how we will know that pin is float pin? What is the purpose of this float pin?
Okay. The clock tree exception where you have actually defined the pin as a float pin. Is that the question?
Yes, sir.
Float pin, exclude pin, stop pin. Okay. I would recommend that first you read a little bit of literature online. I will explain. Okay, I'll give you that. Because first you need to understand what is exclude, what is float, some
sir.
meaning. to it. I can answer the question very easily. Again,
Yes, sir.
the confusion will not go until you read a little bit of literature for this. Okay.
Sir, sir, one thing. Example, if we take floating pin, the floating pin is mainly used to uh, uh, avoid the skew and insertion delay. For that purpose, the floating pin is used. But who will decide that make it that
No,
floating pin?
no. Let me give you at least this definition. You use exclude. Okay. When you don't want to balance that pin, that clock pin with the rest of it.
Yes, yes. Exclude pin is correct.
Okay.
Even
You use a stop pin
Hmm.
exception for the clock tree when you don't want the clock tree to be constructed after that. That means you have
Yes.
already constructed the other portion of it.
Yes.
So that is constructed. I don't want your clock to build beyond that. When you're defining clock stop pin, you have to give like what is the clock balance at that point that you expect.
That is the endpoint for that.
That is the endpoint, but you can define what is the clock skew balance. Like you have already built 1 nanosecond of clock tree after that. So I'll say clock exception of 1 minus 1. I expect, clock balance point of minus 1 nanosecond at this point. That's the way you will define. Then what is a float?
After that point, it has some delay. After that point, that
Your
has some
example,
delay.
example,
Like
there is a
passes
clock.
from input to register macro, then it has some internal delay. So
Internal delay.
if we add that delay also to this pin, we have to set it as a float pin. Float pin means it is also like a stop pin, but as
You read little bit of literature. I'll answer this question. Okay? Because if I explain also, it will be confusing. First, you read a little bit of literature. Exclude stop is easy to understand. Float, you read, it's very easy. But that logic should stick. No, it is something like, sometimes people don't understand the physics. That's the problem. Okay, we'll explain that. Okay. Keep this. It's okay. We'll answer that question. Okay. What else? Any other question?
We decrease the voltage, the whole will fix. But setup also delay will be for setup sense also delay will be the one, right?
It's okay. You'll run it at lesser frequency. No, I've already told. You can run if it violates setup. You run it at lower frequency. You can sell the chip. You already know setup violation is easy. How you deal with it.
Sir, what about custom CTS?
Huh?
Custom CTS.
Custom CTS is what you manually build. Like as I told you, right? You are building this route. Part of it you are actually constructing. Mesh you are constructing. Part of the route you are. So these are all called custom CTS. That means I am manually building the
Manually placing. Okay.
anything custom means it is manual. It is not automated. It is not algorithm driven, but something that you are building unique to this. Custom is not entirely manual. Custom is very specific. Manual means everything is hand. Okay, custom is specific. I'm building part of it. Part of it can be automated. Part of it is like that, but it is specific to this. I'm only doing one. Yes. That's all. That's the meaning.
So actually clock tree building like HX tree or X tree, hybrid tree. From where we will get that information? X tree or H tree.
That depends on your place.
Where you will get, or which one should I choose? What is the question?
From where we will get?
No, that option is there in the tool. Whether you want to build
Algorithm.
a H tree or cluster model, you have the option.
No, sir, they're asking how to choose that particular one.
That one, that's why I asked the question, whether what is, whether
Information only I want.
information, you have that in the tool. You can say construct H tree, construct balance tree. CTS, you have that option, which tree to build. But not all options are not there. Fishbone and all are manual. Okay, but you have HP cluster. Okay, fully balanced, we can, yeah, set clock tree options. Can choose.
Using that switch.
Yes, you can choose. Clock tree has so many attributes, so many switches. You have to learn. That's what you. Conceptually, you got. Now, let's talk about the third part, which is your post CTS hold. Post CTS setup we have spoken. Right? You use your business queue to try and outlet design. For hold, you can run post CTS hold. But if it's adding more buffers, before you run post CTS hold, these are the following recommendations that you should do. Don't run post CTS hold before you do error recovery and power recovery. Yes. So before you do post CTS hold, my recommendation is for you to run error recovery and power recovery. What are these two steps? Error recovery will do that, it will downsize for all the cells which are non-critical. It will downsize those cells so that it will give you some area, or it will unbuffer. Okay, run gate unbuffer, or you can do any of that, PC knock minus unbuffer without actually, without impacting QR, means without impacting any setup QR. It will try to remove some unwanted buffers, because tool is like that. It will go and do that buffer. So some area recovery, some power recovery means what? Power recovery means it will do VT swapping. Not downsizing. Downsizing is area recovery. Okay. LVT to HVT. Okay, SVT to H power, leakage power. That's called power recovery. So what happens is when you do this, when it downsizes, it means the cell delay is increased somewhere. When it is doing power recovery, so SVT to HVT it is doing means it is increasing the delay. That will all help your hold. So that lot of paths will go up. Okay. So PC not, when you are doing actually, when you are running actually hold, post CTS hold. There also first thing you should do is hold fixed by queue. It should not, you should not do blind buffering. Buffering is the last option. First is playing with the clock tree. Do the clock tree skew balance such that the hold violation goes down. You understand? So this is what you have to do. First thing is play with the clock for hold balance. Then you do hold buffering, again not at the end point, start point. Start point hold or critical point hold fix. These are all tools which can be. It can find out this one hold can fix 10,000 violations like that. You understand? So first play with the skew, then you play with the start point hold fix, then you go for the bottleneck fixes, then you go for the end.
For power recovery and area recovery, we have to enable app options.
Yeah, you have app options. You can run that,
And
or you can do, you enable that, or you run PC knock. Okay, final op minus power recovery. Options
Just-
like don't run place op. Post CTS you have created. You have to do final op. PC knock means it will move the cells. Okay, post CTS, you should not, first thing when you are actually dealing initially, you can move the registers. But after that, the register should be fixed. Should not move the registers, because if you keep moving the registers, clock skew will keep changing. You want to establish control. So how you do, what stage? Okay, don't touch registers, you can do, okay, just fixed timing with only moving the data path cells without non-sequential. You have an option like that, non-sequential. You go and upsize only non-sequential. Like that. You can try these options.
But if in CTS we have congestion issue, then same technique we have to apply blockages. Again, we have to do placement.
No. So one of the things I told you, right? Let us say you have 100K clocks in your design. How much should the clock utilization go post CTS? Not post CTS setup or how much should the area increase? How many buffers do you expect? Let's say you have 1 million instances designed. Okay, with 100K flops. How many clock buffers do you think should be expected? How many clock buffers do you expect? All black. No idea. Let's say you have a max fan out of 32. You have 100K flops, right? So the equation is log 32 of 100K. That's the number of clock buffers you are expecting. Means every clock buffer should drive 32 buffers. This is the it's a high fan out net synthesis. So log of 32 should be what the number of buffers. So it would be like some 3,000 buffers or so. That's all you should expect. If you are seeing there are more than 10,000 clock buffers or something, or more than, so the idea is 3 to 5% of the number of flops is what you should have in your as clock buffers inside. Is exceeding more than 5%, there is a problem with your CTS, initial CTS placement. Okay. This is how you have to. Everything is math. There is some mathematics. People. Okay, so you have to look at that, like it should not be more than 3 to 5% of the number of flops. Not the total number of logic. So that means overall, how much should the percentage? It should be like less than 0.5% area growth for CTS. Maybe 0.2%, 0.3% should be your area in terms of clock buffers that should get added. Then post CTS setup, post CTS fold. Should not see more than 1% to 2%. Hold you may take maybe 1 or 2% buffer addition. What type of hold buffers will you feed? Should be used hold fixing. Before you do hold fixing, should not enable all the buffers. This is how you have to play with all the libraries. Each stage you have to control the library. Up to placement, all the clock cells should be hidden. Don't touch. Post CTS, you have to enable only clock cells. Data cells hidden during CTS. Then after CTS, you can enable all CTS cells and this one. Okay. Don't add delay buffers in the post CTS, in the CTS stage also. But after CTS stage, you can enable the delay buffer. Okay. But when you are actually doing post CTS hold, you should enable delay buffer and you should enable only the HVT cells. And maybe 1x normal buffer, because HVT gives you the worst case delay. Right? No leakage, worst case delay. That's the whole point. You want low leakage. So you hold fixing again is of structure. First you play with the skew, then you use start point. Okay, then bottleneck, then endpoint. But when you are using the buffer, the data buffer, use the delay buffers first. Then you can use normal HVT cells for fixing this. And when you are using delay buffers, again you cannot use delay buffers like that blindly. Because delay buffers are very low drive. After delay buffer, you have to use one small buffer. So this delay buffer should be behind a small buffer too. Okay, that's when it will give you biggest. All these are concepts. So post CT, before doing post CTS hold, you have to run area recovery, first area recovery, then power recovery. Don't do the other way around. You get that? Because area recovering area is one. What are the other questions that you can ask? So in a highly congested design, you have timing violation. In a high congested area, you have timing violation. How you will fix? Let's say 100% utilized area. You have setup violation. How will you fix? So, any questions from you guys? Okay. Okay. In this, let me say over here, in this area, it is 100% utilized. There's no space for hold fixing or setup fixing. But there are setup hold violations here. How you fix setup hold? Setup violations are also there, hold violations are also. Let's assume, for example, you have setup violation.
Setup violation means we can see that data path, we can downgrade our, we can remove some down cells.
Which cells you will downside?
Data path.
Data path.
Whichever path, in which data path you will downside? In the path where you have violation.
No, in that particular area, is there any setup violation causing data path? Is there or not? We'll check.
The setup violation is data path, no. So if you have data path setup violation in this particular area, which is 100% utilized, how will you fix? If you say you downsize in that violating path, again the delay will increase. Setup violation, how will it fix?
Decreasing data path. Data path delay path.
How you are decreasing data path delay? Downside, how will it downsize? Upside, you don't have area, no?
Or else we can remove some buffers or buffer.
I think we don't have area.
Sir,
We can remove some buffers.
we can do VT
What will
swapping.
be your logic to remove buffer?
Means to decrease the data means data.
How do you, if you, generally buffer would have been added for some transfix.
Sir, we can do VT
Your
swapping.
answers are not correlating well. See, you have to be very, very clear, right? Generally,
We can do
you're
VT
removing
swapping.
buffer means somewhere previous cell delay is increasing a lot. It's not logical for you.
VT swapping is the option. No.
VT swapping is one option. You can swap HVT to SVT, LVT. That is one option. What other option? So that without touching, we can. What other option?
Can you touch
Metal layer. We can
You
go
touch
to higher
anything.
metal layer.
Then we can do clock pulling.
Clock pulling also, if you have to pull, clock pull means what you will do?
So you will check the margin before that.
Yes. So, but do you have to insert a buffer for that?
Sir, we can touch metal layer.
For clock
can go
pulling
for
not
higher
required, you
metal
may
layer
have to
routing.
tap the previous cell, connect that net. Clock pull means early. Clock pushing is where you have to add one more buffer. Clock pushing is not possible. Clock pulling possible. Okay, that means early. You have to connect to the previous net. Clock pull means
Early clock.
yes. Early clock means there's a buffer here, there's a buffer here. All instead of this one, the endpoint is connected. Clock pull means you will add one stage before. It's only net connection. Okay. You can do that. Clock push is not possible. Because you have to add one more buffer. What else option? Tell me.
We can
Are
go
you
for
kind
higher
of-
metal layer.
Yeah, what's the option, Satish?
We can go for higher metal layer routing.
Yes. Okay, so let me ask you this question. You go for higher metal layer. You are expecting delay to come down.
Yes.
That's the point you are making now.
Yes.
Why? How do you think higher metal layers are going to give you less delay?
Means if it is there any critical long metal layer.
One at a time. What is that? Less resistance.
Compared to downward higher metal level, less resistance.
More
The
with
delay
the-
will-
What is the delay? What is the equation for delay?
Okay. Output delay plus net delay.
R6, R into C. Let me ask you one simple question. You are doubling the width of the net. Okay, doubling the width of the net. Will the delay of the net go down or remain the same or increase?
It will go down.
Increasing.
Width
The
is
delay
doubled.
will reduce. Yeah,
Delay will
the delay-
reduce. How?
yes,
As the length.
because the area of
So
conduction
by
increases.
resistance comes down by half.
Yes, sir.
Okay, because area is double now, cross section. What about capacitance?
It's an A by D. So
Increases.
Area is increased. No?
So
So what
capacitance
happens?
increases. Increases.
This side C is the. So how is the delay decreasing? You tell me. Give me the equation. Delay decreases. Yes, I agree. But how?
The amount of current flow increases.
Huh?
The amount of current
Current-
flow.
There's no current flow in the delay calculation. No, it is R into C.
Yeah, it's R and C.
capacitance it's an A by D now.
Ah,
It's an A by D.
ah.
We are increasing D also now.
How you are increasing D? What is D?
Distance.
Distance. How is the distance increase?
By increasing width only, we are increasing the area.
You are increasing the cross section area. Distance is what? Between the two plates, that is the distance, right? Which are
Yes.
that you are not changing.
Sir,
Ah,
the
these are all like, you don't know the feeling. See, basically, I will tell you. Okay. Resistance, yes, reduces by half because resistance is only net. But capacitance is not only net capacitance. Capacitance, what is the total capacitance for the delay? The total capacitance is net capacitance plus pin capacitance plus ground capacitance. The pin capacitance has not changed. The ground capacitance has not changed. The net capacitance has doubled. So overall effect, what is that? Overall capacitance is not doubling. It is only increasing. So resistance has reduced. Overall capacitance has actually, resistance has become half. Overall capacitance has not become double. It has only increased maybe 1.2x. So you will not see a delay of reduced by half. You will see delay as reduced, but by some quantum. This is for long net. Okay, overall, this is what happens. You have to use this. You have to know what all components are playing into the game. Pin capacitance, net capacitance, substrate capacitance, all these capacitance. You should know, you should read physics. Why you are taught electronics, you tell me. Hello? Yes. Hello, Cholamandalam Finance, huh? Okay. Hello? देखिए उसमें प्रॉब्लम ये है एक्चुअली कि मैं ट्रांजैक्शन नहीं कर पा रहा हूँ चोलामंडलम से. ओके, तो अमाउंट विड्रॉ भी नहीं कर पा रहा हूँ, उसको ठीक से विड्रॉ करने का प्रॉब्लम है, तो ट्रांजैक्ट नहीं कर पा रहा हूँ. ओके, वही प्रॉब्लम है. उसको देखा जाए तो वो ऑनलाइन एनेबल नहीं हुआ करके बोले थे और उन्होंने एक लिंक भेजा। वो लिंक मैंने एक्चुअली क्लिक किया और उधर मैंने डेबिट कार्ड भी यूज किया बिकॉज दे सेड इनिशियली वो जो 3 महीने का है वो सब एक्चुअली एनेबल करना है। तो वो एनेबल किया तो वो बोल रहा है ऑथेंटिकेशन फेल्ड। वही प्रॉब्लम है, वो नहीं हुआ, वो लिंक काम नहीं किया। आपकी सॉफ्टवेयर की इशू है। मुझे दूसरा लिंक भेजने के लिए बोला है, अभी तक आए नहीं। हाँ, मुझे एक और लिंक आया है, मैं उसको ट्राई करूंगा। हेलो, हेलो, I am in the middle of meeting here. Can I call you a little later? Sorry? Correct. Call me around 6 o'clock. Okay, I'll be able to. 6 is fine. 6. Okay, last bit. Running out of time. So I think, they should give you a good preparation for your interview. You learned something?
Yeah, yes, sir. It was interesting. We could get the fundamentals again recalled.
Okay.
Nice.
See, let me talk about few other options, right? So you can definitely swap, you can definitely change the layer. You have to look at, he spoke about, he's not here, but you can explain. But he spoke about actually removing buffers, removing, downsizing the cell. You should not downsize the cell on the critical path. In that area, there are paths where you have positive slack. Where there is positive slack, there you downsize. Don't touch the critical path, not critical path, you remove the buffer, okay, without impacting the slack. So you have to manually, so you create space. In case you want to add buffer, you create space. How you create space is like this. It's not just for timing fixing, it's also for shots. In that area, you have to fix shots. It's highly congested, shots are there, you don't have timing, how you will do? You'll have to remove some buffers. How you will remove? You have to look at the paths which are actually meeting timing. Yeah, wherever you have more positive slack, where it's meeting timing, downsize. Okay, remove buffer, grab that area, create area, and give that area to these things. This is the way you have to do. Like this, I have got so many options. Think.
Mainly out of the chief preference.
See, it depends on what you are doing here. Let me say tomorrow is my takeoff. Today I have to do. I have only 5 picoseconds. Okay. If I just swap to HVT, LVT, my design is done. I don't have to touch DRC. Otherwise, I have to route, I have to run every damn thing, it's a problem, no? So it depends on which stage you are, what is the critical problem you are facing at that point. These are options. There's no golden rule. You should only do this. If I know everything, if I tell this, I don't need you. I can just create a flow, fire, another tool. Right? This is what is AI, what we are doing. Otherwise, all of you have no jobs. Firing also we can do from one machine. Okay. Okay. I did not touch route. Routing. I did not check post silicon also because they have a lot of time, but I'll have to do some editing protocols and all also. But I hope the preparation is good. But if the requirement is, we'll have tonight. We'll have a call maybe this web around 8 o'clock or so. Okay, think about the questions. I'll set up another call. We'll have a session from home. I'll do, but right now I'll have to send the profiles. That's fine. We'll discuss route. We'll touch some things. Any other question? Quickly, last 2-3 minutes.
Sir, one more thing.
Sir,
Sir, what about to build the clock tree, clock buffer and clock inverters, which is better to?
clock inverters or clock buffers, which is better,
Yes.
right?
Yes.
See, the point is you should use both. Okay, clock inverters have a lesser area and probably, because it can actually switch in that one, I would prefer clock inverters. Okay, but while doing all ECOs, don't use any inverters, use only buffers. Okay, clock buffers can drive more length. For levels of logic, clock buffers is always preferred because clock buffer will be able to drive more length. Okay, because it's able to drive more length, the number of switching will reduce. For power point of view, clock buffer. For transition, timing, insertion, clock inverters. Because more the number of switching, more the power consumption, right? Dynamic power consumption. Clock buffers can drive a longer distance.
Yes. Transition is high in that. Okay. Sir, one more thing. What is the difference between clock inverter and clock inverter pairs?
Clock inverter pair, right?
Yes.
Two
Two
clock
buffers.
inverters.
Two
So
buffers
instead of
is
one buffer, you have to use clock. You have to use inverter means you have to use inverter pair.
okay.
Unless you really want to do an inversion of the clock, right?
So clock inverters have smaller area compared to clock buffer.
Yes. Smaller area, clock inverter characteristics are smaller area. Okay. But lower drive strength. Lower drive capacity cannot drive longer. Any other question? Sorry, Suryavel, you are asking something.
No, sir. If possible, tomorrow or a little later, you please share your thoughts on physical verification and STA.
Yeah, we will discuss that. Okay.
Yeah. Yes.
CTS have just brushed at the surface level. Okay.
Yes, sir.
At least the other topics I have touched 1%, I would say.
Yeah.
CTS 0.1%.
But it was
Very
interesting.
high level. But from an interview point of view, only I have actually spoken what you have to do,
Yes.
how you have to solve, how you have to debug. This should help you. Okay.
Yes.
And post CTS also, you should enable CAN reordering. Okay, clock domain based CAN reordering during post CTS because now it will look at skew group and accordingly reorder so that if the two flops are in different skew groups, then you have a problem. The skew will be bigger than so skew group can be enabled. Skew group based clock chain reordering can be enabled during post CTS. So that in hold fixing will add minimum. Okay.
Yeah,
That's
sir,
it. Good.
Sir, a
Yeah.
second. If there is a meeting tonight, please let me know. Please share the link. I will also try to join.
Yeah, no problem.
Yeah, yes.
I'll keep Banaja informed so she will copy that.
Okay, sir. Fine.
Okay. Hopefully this was useful to you. All the best.
Sir, one more thing. Last question.
Go ahead.
Sir, the skew grouping is mainly done to reduce the latency.
No, create skew group. Yeah, skew group is basically done to isolate. Okay, different clocks from balancing each other. Okay, this Q group, this is another Q group you create so that you don't actually really care about clock balancing between these two things. Okay, and you have to make whenever why you have to make this, let's talk about one thing, right? Setting false path between clocks and setting the clock asynchronous. What is the difference?
I have that question. Synchronous and asynchronous.
Asynchronous and false path.
Yes.
Should you add it as a asynchronous or should you add it as a false path? Set false path between this clock and this clock.
Asynchronous
Why?
should be set as a false path
False path.
because it's have a clock domain is it's have clock crossing domain.
Asynchronous means what?
It is
The
have clock
launching
crossing domain.
launching clock will have a different clock, and capture clock will have another clock.
Huh?
The launching clock and the capturing clock will operate on different frequencies.
So what?
I mean,
So should
yeah,
that
so
be
that,
false path or async? What
no,
is
no.
the difference between setting it as a asynchronous clocks versus setting it as a false path? Set false path minus from clock group 1 to clock group 2 or set asynchronous. Okay, clock group clock 1, clock 2 asynchronous. What is the difference? Okay, the difference is this. For both the cases, it is treated as a false path. In the sense that there is no connection between this clock and this one, but I will tell you the difference. The difference is if you set it as a false path, okay, whatever crosstalk happens between this clock and that one will also not reflect if you have set it as a false path. But that is not true. In reality, if there's a crosstalk, this clock is there, and this clock is short. This transition should impact the other clock. In asynchronous, this crosstalk will have effect on this. That's the physics. If it's sharp wise, it will create a crosstalk to the other clock. The crosstalk effects will still be valid if you are treating it as a asynchronous. So this clock edge will move because of the crosstalk of that. If you have set it as false, noise makes, so these are things, but I think now in software it could have been taken care. But keep this in pause. Okay. All right. Thank you.
Have a good evening. Thank you.